So this question was asked in GATE 2016 Electronics and Communication Engineering paper set 3, in which you have given signal x of t, which is a convolution of sine of t upon pi t and sine of t upon pi t. So it is a convolution of two sinc functions. So you need to find out the value of x of t. So the NPTEL reference for this question is Principle of Signal and Systems by Professor Aditya K. Jagannatham, IIT Kanpur. You can find reference in the lecture, which is Properties of Fourier Transform Part 2. So the useful data for this question is, if you have given a signal x1 of t and another signal as x2 of t, and if you multiply these two signals in time domain, which is x1 of t into x2 of t, then in frequency domain it will be convolution of two spectrums, where x1 of f is Fourier transform of x1 of t and x2 of f is Fourier transform of this signal x2 of t. Similarly, when you convolve two signals in time domain, which is x1 of t and x2 of t, you are convolving these two signals in time domain. So in frequency domain, it will multiplication of their corresponding Fourier transforms. So it is x1 of f into x2 of f, where x1 of f is the Fourier transform of x1 of t and x2f is the Fourier transform of x2 of t. Now, the second useful data for this question is, if you have given a rectangular signal which is from minus tau to tau and amplitude as a, then the Fourier transform of this signal is 2a upon omega into sine omega tau. So this is the Fourier transform of a rectangular pulse. So by using the duality property, which is given as, if you have a signal f of t whose Fourier transform is given by f of omega, then you can write the Fourier transform of f of t as 2 pi times f of minus omega. So you are just changing this argument omega as t and you are getting capital F of t. So the Fourier transform of this capital F of t will be given by 2 pi times small f of minus omega. So this is the duality property of Fourier transform. So by using duality property, you can write Fourier transform of this 2a upon t. I am just replacing omega by t. So you will get 2a upon t into sine t times tau. So the Fourier transform of this signal will be given by 2 pi times of this signal and inverting in the time domain. So it is 2 pi a, and this limit will be minus tau to tau. Now this axis is omega axis. So by using duality property, you can find the Fourier transform of this signal 2a upon t into sine t tau as rectangular pulse in the frequency domain. Now, coming to the solution, you have given a signal x of t, which is equal to sine t upon pi t, and this signal is convolved by itself, which is sine t upon pi t. So now convolution in time domain is given by the multiplication in the frequency domain. So if you want to find x of f, then you need to multiply this Fourier transform x1 of f into x1 of f, where your x1 of t is this signal sine t upon pi t. So if this is x1 of t, so similarly this is also your x1 of t. So when you convolve these two x1 of t, then in the frequency domain it will be the multiplication of this their Fourier transforms. Now you know the Fourier transform of this 2a upon t into sine t times tau is given by a rectangular pulse which is from minus tau to tau and the amplitude of 2a pi. You can find this one in useful data slide. Now, when you compare this by this x1 of t, which is sine t upon pi t, so when you compare this, you get 2a equal to 1 over pi and tau equal to 1. So by putting these two values in this expression of Fourier transform of this signal, you get the Fourier transform of this sin t upon pi t, which is rectangular pulse, which is from -1 to 1 and amplitude of 1. Now, to find out the Fourier transform x of f, which is the Fourier transform of this signal x of t, which is the convolution of these two sync pulses, you need to multiply the same rectangular pulse with the same rectangular pulse, which is from -1 to 1 and amplitude of 1. So when you multiply this, you get same rectangular pulse, which is from -1 to 1 and amplitude of 1. Now you get x of f as a rectangular pulse, which is from -1 to 1, has an amplitude of 1. So inverse Fourier transform of this one is same sinc function, which is sin t upon pi t, because you find out the Fourier transform of this sin t upon pi t is the rectangular pulse in the frequency domain. So by inverse Fourier transform of this rectangular pulse, you get the corresponding x of t as sin t upon pi t. So the correct answer for this question is option A.